Thanks, Neil. Good afternoon. And thanks for being so brave to put a chemical industry up here after having automotive, aviation, all the cool stuff. And thanks for joining on that little journey. My name is Ralf Düssel. I'm working for Evonik. Evonik is a specialty chemical company, 15 billion revenue euros, and roughly 33,000 employees globally. So that should be the commercial part of the presentation. And otherwise, I'm now 5 months in the role. Before I did run several businesses for Evonik. So please judge me on how holistic I can be after 5 months. So I will try to do my best. What is the chemical industry? I heard this morning already that the chemical industry is very complex and very connected. And you see here a view on the chemical industry. At the very bottom, of course, crude oil, natural gas, and so on. The naphtha, and then you have a ton of different chemical reactions, then adhesives, all the different kind of applications, and at the very end, the end user products. So it's quite a complex industry, roughly depending or generating 1.4% of global GDP, but because of all the interconnections, roughly 7% influence on the global GDP, and more than 14,000 companies globally. So you see, making this industry net zero is a highly complex thing, and you really need to consider the entire value chain. And that's the main pitch. I would say we need to work all together to make that net zero. So that's a little glimpse on the chemical industry. If you look at greenhouse gas emission of the global chemical industry, it's roughly 6.6% of the global greenhouse gas emission. You see the chemical industry in the middle, and roughly 1/3 is from heat electricity. Right? We need electricity, no question, but also heat to do the reactions, to do separations. It's necessary. The other 2/3 come from energy usage upstream in construction. So our scope 3, so to say. And you see which are generating, so CO2, but also some fluor gases are contributing to our greenhouse gas emission. And that's global, entire chemical industry. It's not animated. I wanted to ask a question. Because I'm working now 27 years in the chemical industry, and putting this together, I asked people, what is the biggest chemical in the world? Any idea?
Ammonia.
Not bad. That's normally the answer I always get. It's number 2. The slide would have been animated and I learned this morning or this afternoon, aviation fuel is the same amount like the largest one. And if somebody says here natural alcohol, not a bad idea. That's 50 million tons per year globally. But the largest one is sulfuric acid. And then ammonia. And both are mainly used for agriculture. But then you see the other things like methanol, propylene, polyethylene coming. But what is important on the right-hand side, you see the impact on greenhouse gas emission. And that's the reason everybody says ammonia, because that's by far the largest greenhouse gas emission impact. You often see even diagrams with chemical industry without ammonia, because otherwise it's distorting a little bit the picture. And that's what we need to work on, right? That's what we need to focus on. And we are doing that. And we are not only influencing the greenhouse gas or generating CO2 to the environment, we have also other impact on the planetary boundaries. And you see some examples here on the upper right-hand side. Of course, we contribute to novel entities, try to reduce that, for example, here with microplastics. We have aerosol from our combustion processes, for example. Or here, freshwater withdrawal. As our company, maybe I throw some numbers in, we use roughly 1.5% of our water is in fresh water. The other one is recycled. And of course, if we use more bio-based material, we have an impact on land use and also on biosphere integrity. So as chemical industry, we need to look not only at greenhouse gases, but also on the other impact we have on planetary boundaries. But let's look maybe to CO2 first. That's globally this chemical industry. And you know scope 1, 2, so the electricity heat we generate ourselves or buy, is roughly 25%. So 25% we have our own control of our CO2 emission. 75% is so-called scope 3. It's coming mostly from upstream. So from our raw materials we utilize. So here we need to work along the value chain and work with our suppliers to reduce the carbon footprint. I put some Evonik numbers in here. And for 2023, I will tell it later, so 6 million tons we have CO2 in scope 1, 2, which is roughly 21% of our greenhouse gas emissions, and 79 is in scope 3, so similar to the entire chemical industry. And roughly 90% of here, scope 1, 2, is energy. Energy meaning heat and electricity in our scope 1 and 2. And here, more than 50% of our scope 3 is raw materials. So, and that's pretty typical, I would say, for specialty chemical industry. And what can we do to reduce all the impact, greenhouse gas and the other impacts? You see the value chain of today. It's very linear. You only see one loop. It's roughly 5% is mechanical recycling. And we have a very small biomass intake here. It's larger than 1%, but it's not huge yet. And fossil then is 94%. And we go to the end user, and you see here still 21%, for example, of our products at the very end go to landfill. I have the pleasure also being president of Plastics Europe Germany. It's a plastics producing association. We don't want to have that happen, right? We don't want to have our products going to a landfill. They are raw materials for the future. And if they are landfilled, tough to get them back. So we need to reduce the landfill, definitely. Still some open burning here. And how should it look then? 2050, that's from System IQ and scenario for net zero. First of all, we have way more biomass, nearly 30%. Fossil is still there, 12%. And we have direct air capture. We talked a lot, you hear it in every speech more or less, right? Carbon capture, utilization, direct air capture. We need, and I think that's the main learning from that picture, because it has a lot of information, we need all technologies. We need to be open for all technologies, and we need them all. And that's the reason we should also work on them. We still have landfill. Nevertheless, we have way more recycle. Mechanical recycling, 21%, but also depolymerization or pyrolysis, so chemical recycling. We need that. We are working on it. The entire chemical industry is also waiting for certain regulation from Europe that chemical recycling in plastics counts towards recycling quotas, which we support. So, and on the other hand, you see there will be elimination, design for recycling, and also substitution. So we all should work towards that goal and be very open for different technologies. And how do we defossilize our own emissions? And you see here a time scale, 2020, 2050, and over time there will be different technologies coming. Right now what we are doing, or a lot of doing, is, let's start here, the coal generation is switched to gas. We have a big coal fire plant which we just shut down, would have been shut down several years. Ukraine war, government asked us to run the plant longer. We're switching to gas, well, it's running on gas, and the gas, of course, power plant is capable also to utilize hydrogen. So at one time, this one goes into hydrogen, right? At one time, when it's doable, but before we can use hydrogen in a more efficient way to burn it in a power plant. We are working on renewables. We are right now at roughly 50% PPA assigned as Evonik, and in 2030 we will be 100% green electricity. Then also here's a topic, clean hydrogen. We need hydrogen as molecule for our reaction. Where do we get it from? We are working on electrolyzers to make them more efficient. Right now, I would say probably 5 times the price of normal generated hydrogen, the green. And we need it at least going down to maybe factor 2. And by that time period here, at one time, carbon pricing will kick in and makes it more profitable. What we are also working right now is on heat pumps. You hear that a lot. We have in our chemical plants often higher temperature, lower temperature between different plants or single facilities, so we can connect them and also use electricity. And over the entire time, and we do that a long time now, we need to increase our efficiency. I didn't mention the number for 2023 on our CO2 emission. CO2 unfortunately went down for Evonik. For the environment might be good, I'm not sure if somebody else produced it, because we produced way less, right? Chemical industry right now is not doing perfect. So production goes down, CO2 goes down. Unfortunately, the efficiency is not going up, right? Because you have a hot plant, you utilize the plant, but it's not fully utilized, so you produce more CO2 per kilogram produced. Nevertheless, overall, last year, our CO2 emission, in our case, went down 15% on a scope 1, 2 level. And over time, as I said, this holy grail, carbon pricing, if this kicks in more and more, this gets more beneficial. And if we consider now doing all that, there are different studies, and they come pretty close to same numbers. If we want to be up to 2050 fully net zero, we need to invest roughly as chemical industry over the time frame 500 billion until 2050. Over 30 years, 500 billion, 17 billion per year. Sounds doable. So the numbers, so it's financially doable. It's only a small part of the GDP if you consider GDP. And if you consider then, let's say, if you consider that, then methanol would be 30% more expensive, ethylene 50, propylene 90% more expensive. And you see here's a price per ton, being fully green and today being fossil-based. So if you consider this roughly, let's say everything is double the price, then you see here's a final consumer cost increase. And probably some of you have seen it. It doesn't seem to be a significant amount. So for a car, you see sometimes it would be 1,000 euros more if the car is complete green, right? Steel, plastics, glass, whatever, which correlates depending on how expensive the car is. Nevertheless, similar number, right? So it seems to be doable also here in food or in soft drinks. Nevertheless, today, as we are hearing here or yesterday at other conferences, it's very tough to get the value chain paying at least the amount which it costs more. But for me, the positive thing on that, it's doable. We are moving that way, and it will change over time. And we have not only an influence on CO2, we can also, as chemical industry, have an influence, a positive influence, on the planetary boundaries. For example, you saw this loop on circularity, right? Be it mechanical recycling, chemical recycling, that needs to be closed, and you need additives, you need technologies to close this loop to really reduce here the impact on novel entities, which we can do with our additives. We can have also additives to increase the usage of feed for animals, and therefore also reduce their nitrogen or CO2 or N. Let's say also here in our manufacturing processes, we have possibilities to reduce our CO2, but also make the manufacturing process of our customers more efficient, less CO2 or other emissions. And the last one here is in energy transition. The chemical industry has a variety of solutions how to make energy transition more sustainable and faster. One example you all know is, of course, windmills, but we have also gas separation membranes, so that you can feed hydrogen in a normal natural gas pipeline and get it out again. So you utilize existing pipelines. So you see a variety of examples where the chemical industry have a positive impact and really help to be in planetary boundaries or to get back into it. And that's how is Evonik looking at it. CDP is gone. Nevertheless, I'm happy to say we are SBTi committed. 25% reduction in CO2, scope 1 and 2, from 2021 to 2030. This is this year, and in scope 3, 11% reduction. And I mentioned some example, like the membranes, or if you consider a tire, we can improve the efficiency of tires so that they don't have such roll resistance. And we call those solutions which have a better impact in the application for our customers than the next best solution. We call them next generation solutions. Last year we had 43% in our portfolio. We can also measure that and show that. We want to get to 50% by 2030 and reduce challenge products. That could be substance of very high concerns or other material which we want to reduce in our portfolio. I will skip the other targets. And my summary is, so we are, you saw that, an entire or a very important part of the entire value chain. So we are part of the transformation. We have started the journey together with a lot of you, it's different partners. The technologies are mostly existing. We still need technology development, there's no question. We need new reactor technologies and continuously. But we have a lot of technology today. The financing seems to be doable. Unfortunately, often not yet a business plan there. And we need a level playing field. So that those technologies develop, we need certain regulations, we need carbon pricing. And what is important, to close those loops, to generate all those recycling. We cannot just work alone. We need you and others to close those loops, to work together at the value chain. And that's the reason we are happy to talk here, but also we invite you to talk to us to make that happen. Thank you very much.
Thank you very much, Ralf. Any questions from the room? Yeah, immediately at the back. Means I've got a long way to go. Do bear with me.
Thanks for the interesting presentation. You mentioned the use of bio-based feedstocks as an input into a more sustainable chemical industry. What about the use of biotechnology, so using biology to do transformations? Do you see that playing an important role?
Yeah, definitely. We have a lot of fermenters ongoing, right? So to use bio-based technology or biotechnology, and we see that as a big advantage. We just launched one product. Now I'm talking more Evonik. Want to keep it more chemical industry, but we just launched rhamnolipids, which is a bio-based, biodegradable detergent with a big detergent company, and this is also then a perfect example of that.
I would just follow up in that question. When I think in synthetic biology, particularly E. coli yeast, if you project in the long term, the use of feedstock needed to feed those organisms is going to be a new challenge eventually. What are your views on the use of photosynthetic organisms like cyanobacteria or microalgae to do these new chemicals?
Yeah, right now for us, it's talking Evonik, it's really R&D work, right? For totally new reactions. As I said, we have certain bio-based products. We're using bio-based products, and we see that as a big potential, right? You have lower energy cost often, or lower energy intensity. You can also, and that's what we are working, for example, on our scope 3. Our raw materials, can we replace our raw materials with raw materials produced in a different way? also with low energy. And there we are looking into it.
Jerome from Good Carbon. Thank you very much. Can you give us an order of magnitude when you say biofeed input? How many tons are we talking about, and which conflict does it create in sourcing it? Also, is there a land use conflict which you generate?
Yeah, definitely. You saw two things right here. It's at 2050, it would be 30% based on that scenario, which you can always talk scenarios, but if you compare certain, you have this range, 20 to 30%. People say we need biomass, of course, and then you have the other thing here, which I showed, right? Biospheric integrity. So you cannot totally go by biomass. So I think that's the reason also for the other slide, you need all technology. Biomass is one part of the solution, but not everything, because you need to keep this also in mind. Otherwise, you could totally go to biomass, landfill it, but that doesn't work, right?
If I could ask two quick questions, one following on the previous question. So if not biomass, then do you see a future where you actually use CO2 as feedstock for chemicals, even though it's very, very expensive right now? And then two, you mentioned the importance of carbon pricing, and I'm just wondering for your industry, what are the main mechanisms of carbon pricing that you see coming in? For other heavy industries, maybe it's a CBAM, but I don't think that is applying to you guys right now. So are you seeing like consumer-driven green premium, or are you seeing like potential regulation coming in similar to CBAM for you guys?
Yeah.
Thanks.
So maybe to your first question, where do we see carbon capture utilization? We see it as a need, it's coming. We also develop technologies that to make it happen. We have catalysts, right, to utilize green hydrogen for carbon capture utilization. Today, to my understanding, it's all pilot scale. I hope I'm not, somebody's disagreeing here, but it's coming, right? You need it, and if you have green hydrogen, then it's a good potential. So, and it's also in here, right? You even have direct air capture and point source from CO2, which you utilize here, right? So you have your part in here, 12% on that carbon capture utilization is in here, even if it's not written this way. And the other question was CO2 pricing. We have CO2 pricing in our investment calculation for years now. Right now in the ballpark of 50 euros per ton. That doesn't change the needle a lot, but it goes up, right? Today we have our certificates still, but if you look at 2030, we are probably more, I'm not the CO2 expert here, but in our calculations more 100, 120 euros, and then things change. Then certain things you saw on the scale, which technology then gets viable, then it's changing. And of course, when you go to 200 euros, it's another world. I hope that answers your question.
Hi, Roberta from Brunswick Group. You mentioned that you would need some regulatory measures in the years ahead, and coming from Brussels, where the Antwerp Declaration from the chemical sector made a lot of noise about the need for the chemical sector and the energy-intensive industry to stay competitive while decarbonizing. So my question is really, what would you need on the regulatory space? Thanks.
Right now, as I said, representing Plastics Europe, our big interest is get this stream here, those two streams approved towards recycling. Because right now, only mechanical recycling counts towards a recycling quota. And there are big chemical companies who want to make significant investments in chemical recycling. But if Brussels doesn't, and they're close to, hopefully that this is, can be counted as recycling quotas, then there will be investments, and I think I'm personally convinced it's good for the environment, because then we close this loop. We are not going to landfill or somewhere else. And it's often you hear it's more energy intensive. We say, of course, you should do mechanical recycling wherever you can do, period. That's no question. But there is stuff which you cannot. If you think about windmills, mechanical recycling, so far at least there's no way of mechanical recycling. You need chemical recycling. And there would be one wish towards Brussels, that this will be decided soon.
Hello, I'm coming from a textile sector, so my question may or may not apply to you. I don't know much about Evonik, sorry. Just going back to the gentleman's question on biomass sourcing, that where I've seen that within China, they've already placed restrictions that whatever the raw material for the recycling industry or is coming from within a region. Do you see that when you use biomass as a feedstock and sourcing of that biomass within regions will create further issues and shortages, and how will that affect the global manufacturing industry in general?
Yeah, I think the demands, and for a good reason, are increasing on biomass, right? We are, in our companies, for example, we are using palm oil. We are not a big, we are specialty chemical companies, so our volumes in comparison to others are not as big. But for palm oil, there's this RSPO, as you probably know, right? Responsible sustainable palm oil. Something is wrong here, right? But RSPO, which then really should help to make the plantations sustainable. There are other chemical companies also supporting other initiatives for other bio-based materials. So I think we need to ensure as industry that if you use biomass, it's used in a sustainable way and not having other negative impacts on the environment. And the pressure is increasing on that, which is good. And therefore, I'm not concerned there for the long term.
And is there a connection, is there already ongoing efforts between the chemical industry and the agricultural industry?
Yeah, there is. Like RSPO is, I think, a very good example, but there are others to make sure that the biomass is sustainable produced.
Is that part of the calculations?
In here, in the System IQ, I would guess so. I have to admit, I will look into it afterwards. I take this as a homework, thanks. But I would guess so, because and it's not only them, they try to do a holistic picture. That's the reason I like that, really, because they look at all different kind of influences, and I'm pretty sure they use also or consider the influence on land use and biospheric impact.
Okay. Thank you very much indeed for your questions. One of the pleasures of closing a stage is you can get all the questions in without having to interrupt anyone or disappoint anyone. So Ralf, thank you ever so much for your time, and a warm round of applause for Ralf. Thank you.